to account. So to build up this model, we identify 3 kinds of actions in the SEMPER project: preventive actions, rehabilitation actions, and assistance actions. The proactive, it's based on stimulation, etc. Another proactive, reactive, is based on supervised exercise, chores, recognition, and then assistance. That's more practical. Support when there's an urgent problem, or support to this personal autonomy. In our telematic engineering department, we do not focus only on sensors and electronics or the hardware or the sign processes. We're based on semantics and data communication and information services along these lines. So then our general architecture of SEMPER that we presented in 2006 in the ECOS Congress, and I recommend you to see that Smart Homes and Health Telematic Congress. Every year it's held in a different place. Well, there we have we talked about a general idea of what the system of digital home could be. And this system, and I need to acknowledge here that I didn't research too much before doing that a few years ago, but it does coincide quite a lot with ambient intelligence and what we've been talking about in 2008, 2009. Basically, we focused on the knowledge base, so that from a logical reasoning approach, everything which is linked to that hard work, such as sensors, communications, and everything that comes through that multimodal user interfaces can be managed so as to produce some services and control the quality of those services from the telematic and more functional point of view. And this diagram of large blocks is translated in the following way. When we see this house in the SEMPER project, and by the way, the logo is this moon, because Esther Gago told us that the moon is also intelligence and wisdom, and we wanted to have this moon as a logo, intelligence, this open home with that person always protected. And we thought maybe about an American film with that boy sitting on the moon, or maybe we were just asking for the moon. I don't know. We can talk about our logo during the coffee break, but this is our logo, because sometimes we are asking for the moon, but the moon does exist. So how is our reasoning to take care of all of this? And we can also talk about the e-care here. Well, we have the whole processing system with a multi-agent platform approach. We can use Jade and other systems. I started working with these platforms in 2000, 2001, and in R&D we talk quite a lot about this. Then we have the processing agents, reasoning agents, control or subsystems, and then through technologies, register and input elements can provoke some reactions, both internal and external to the home. And what does this mean? Because right now I'm not going to get in all of the technical details of the whole process. This means that we can help in the decision-making process on the actions that have to be implemented, taking into account that context, that world, the world that we are in at that moment, the present status, the past, because this is also important for the feedback, the reasoning feedback, and also the user interface relationship, which is also important, always important for the dweller in the home. And also this has been growing through this reasoning system, and we use Pellet, which is quite usable, and if it's widely used and easy to use for those who are not experts in artificial intelligence. And then we base all of this, well, we relate all of this with the chores and the internal and external issues in the home. So how does this translate? It's easy to understand. There's a prior situation to an event, such as, for example, falling down. Then there's the event. The dweller falls down. This is detected partially or totally. Certain uncertainty is there. We get the data of the context. We analyze. We take the decisions. And then an alarm is sent outside based on on the experts and users' expectations, and that has to be validated. So this is the situation. In order to build all of this in the SEMPER and intelligent e-care, we need to define the knowledge bases. It is quite well consolidated here. We also use ontologies using OWL and others. I like OWL and the ontology for language here because it's owl in English, and it's like a pun again, where it's like the owl watching intelligently, and it's also the owl language. So we had to define all of this language, this low-level language, which is based on XML and other languages. We have also used Portes itself so as to simulate, so as to see if the system reacts adequately and accordingly. And since we could not go to experts to tell them whether the system works or not, or if we could validate the ontology, or if it reacts according to what's expected, and since right now we cannot say, okay, we're going to connect this with the different sensors that are there, because this is very complex, we decided to do the following. We will have a graphic user interface of the reasoning module that can tell you if this, and this happened from this personal sensors approach or ambient sensors approach with this personal profile. These are the proposals of the intelligent digital home. We connect this with the communication sensor input, and we customize this, adapt it to the context. We connect this to the domestics of a home and also the communication mobile system so that it calls somewhere. And based on the demand, we improve the ontology with feedback based on the experience. And then we have this application, which is at the top on the right-hand side as a picture. And here I have this in my laptop, and I need to talk with my computer because it's 1 giga. It's not really 4 giga. It's not like it's not that I need a supercomputer. It's just a laptop. We've tried this in several computers, and also we have been trying this on PDAs, and then we can detect an efficient reasoning in a technology which is relatively portable, using Java. And how does the simulator works? Well, it simulates the sensors, but not the reasoning sensors, but because it reasons in real time itself. So then we say the following. Okay, we have someone who's living on his own at home. I click here. House chores here? None. Outside the home? None, because the person lives on his own at home. And then we activate the smoke sensor. So what is the action suggestion? Inside the home, open windows. And outside the home, well, we have already sent some data, because if, well, we say yes here, not no, because in this human factor model, well, we like this human factor model because it's a business model as well. I'm not going to talk about this here in this presentation, but we send the data, we call the fireman, and also the medical care team. But what we see here is that there are some alterations. That's what the sensor says. And he's fallen in the bathroom. So if he lives on his own at home and the dweller is on his own at home, and he has fallen in the bathroom, and he's lying down on bed, and he's not walking properly, well, there's something that's not quite working well here. So the sensors are not working well. So we can call the company to verify and check the sensors, because there's some sensors there that are not working well. But since there could be a problem, just in case, we're going to open the windows because the smoke sensor was there, and we're going to call ER. That's the first thing that we do. And we're going to call the fireman as well. If the smoke sensors are deactivated, and you can see how fast this is being done, well, then the smoke sensors are deactivated, and the other options are still on, but not the fireman option. So here we can see a complex reasoning chain. Mathematically speaking, this is not approachable from a neuronal network because the combinations of 15 sensors, in this case, both personal and ambient sensors, without talking about the profiles, with all of these combinations taken 1 by 1 or 2 by 2, 3 by 3, up to 14 by 14, these are thousands of values, thousands, if this is binary programs of 0, 1s, and we have to associate thousands of 0, 1s to those. I mean, there's no expert who could do this association to build all of these patterns and to create a network. We needed to use another technique here. In the next part of the project next year, if there is a continuity, we hope there will be a continuity, we wish we can compare this with other techniques. But for the time being, this is the only one that has enabled us to tackle the problem. Okay, I've been talking far too long. I don't want you to remember my family too much, only due to personal reasons. So I will wrap up here with this small demo. And finally, in conclusion, I would like to add, and I have the image over here, well, that challenges as linked to people, well, the challenge is that the approach should be based on the dwellers and their family members. The system should be accessible, affordable, and safe. Otherwise, there's no intelligence. I mean, to me, there's no issue if they're not accessible, etc. And also, we need to focus on the dwellers' needs, because many times we say, okay, I've already worked with these users in other groups, so I already know their profile. This is not true. As a relative of mine says, well, we're all a world on our own, so customization is important. We need to take it into account. And also, it's good to sell, but this is another issue. And technologies, of course, the challenges are in the in ambient or dweller relationship and other kind of relationships, and there are others. These are different bottlenecks, sorry. And then with the width that's also important, connected both inside and outside the home, because that's important for all of the necessary reasoning. And what is also very important is that suppliers or operators of preventive care, rehab, assistance teams, etc., they should be willing to offer some answers to this intelligent digital home, because if this process is so complex, and then we need the outside answer or response, and if we don't have this response because it's not by business model or it makes no sense to me or whatever, we have been generating some impressive expectations, but we haven't done it in an intelligent way because they cannot be met. And basically this is all. Thank you very much. I don't know if Enrique is around.
Bueno, pues muchas gracias, Miguel Ángel.
Thank you, Miguel Ángel. We are accumulating delays, but of course it was worth a while, and of course the slides were definitely more explanatory. We're going to hear Mrs. Sadu Torre from Fundación Vodafone Foundation in Spain.